Welcome to G Fun Facts Online. Your body is a living history book. Every meal you eat, every breath you take, and every product you use leaves a mark. For most of human history, that story was invisible. But now, scientists are learning how to read it. They can analyze your blood, your hair, even your teeth, and tell a story about the world you live in. This science is called human biomonitoring, and it's revealing the intimate and sometimes unsettling connection between our environment and our health. Today, we're going to read some of the incredible stories our bodies have to tell. Biomonitoring is essentially the science of measuring chemicals within the human body. Think of your body as a meticulous archivist, keeping a record of your chemical encounters. These records are stored in different places and tell different parts of your story. A urine sample, for instance, is like reading the last page of a diary. It tells us about very recent exposures, chemicals that your body is currently processing and trying to get rid of. It's a snapshot in time. Blood is a bit different. It shows us what chemicals are currently circulating through your system, on their way to different organs or to be stored. It's the active chapter of your chemical life. But what if we want to look back further? For that, scientists turn to hair and nails. As they grow, they incorporate chemicals that were in your bloodstream. A strand of hair can act as a timeline, showing exposure over weeks or even months. But the most remarkable archive, the one that holds secrets from deep in your past, is found in your bones and teeth. Certain chemicals, particularly heavy metals like lead, can be stored in our skeletal system for decades. By analyzing a baby tooth, scientists can get a picture of the chemical environment a child was exposed to in the womb and during early life. It's a permanent record, a chemical birth certificate written by the environment itself. This ability to read our body's chemical history is not just an academic exercise. It has been the driving force behind some of the greatest public health victories of the last century. Let's talk about lead. In the mid-20th century, lead was everywhere. It was a key ingredient in gasoline, it was in the paint on our walls, the solder in our food cans, and the pipes that carried our drinking water. We now know that lead is a potent neurotoxin, especially harmful to the developing brains of children. Even low levels of exposure can lead to reduced IQ, learning disabilities, and behavioral problems. The problem was proving the link on a massive scale. This is where biomonitoring became the hero. Starting in the 1970s, the U.S. Centers for Disease Control and Prevention, the CDC, began a nationwide program to measure lead levels in the blood of the American population. The results were staggering and undeniable. They showed that children across the country had alarmingly high levels of lead in their bodies. The data created a clear picture. As lead was phased out of gasoline, blood lead levels in children plummeted. This biomonitoring data provided the irrefutable evidence that policymakers needed. It directly led to the ban on lead in gasoline, paint, and plumbing. Between the late 1970s and today, the average blood lead level in American children has dropped by over 95%. It is a monumental public health achievement, and it was made possible because we learned how to read the chemical story in our blood. But for every victory, there is often a tragedy that serves as a powerful warning. The story of Minamata, Japan, is one of the darkest chapters in environmental history. In the 1950s, people in the coastal city of Minamata began falling ill with a mysterious and terrifying neurological disease. They experienced numbness in their limbs, tunnel vision, slurred speech, and uncontrollable convulsions. The local cats were seen having seizures and falling into the sea. The cause was a local chemical factory, which for decades had been dumping industrial wastewater containing methylmercury directly into Minamata Bay. This highly toxic form of mercury entered the food chain. It accumulated in the fish and shellfish that were the primary source of food for the local population. When scientists finally investigated, they used biomonitoring. They took hair samples from the sick residents and their families. The results were horrific. The hair contained levels of mercury hundreds of times higher than what was considered safe. The chemical record in their hair provided the definitive link between the factory's pollution and the devastating illness, which became known as Minamata disease. The disaster was a brutal lesson in what happens when we ignore the connection between industrial pollution and human health. It stands as a permanent reminder of the stakes involved and why monitoring our environment and ourselves is so critically important. Today, the chemical landscape is vastly more complex than it was in the era of leaded gasoline and the Minamata disaster. We are now surrounded by a symphony of synthetic chemicals. They're in our furniture, our cosmetics, our clothes, and our food packaging. Two groups of chemicals are of particular concern right now: PFAS and phthalates. PFAS stands for per- and polyfluoroalkyl substances. They are a family of thousands of man-made chemicals known for their ability to repel water and oil. This property makes them useful in everything from non-stick cookware and grease-resistant pizza boxes to waterproof jackets and stain-resistant carpets. The problem is, the same chemical bonds that make them so durable also mean they don't break down in the environment or in our bodies. That's why they're nicknamed forever chemicals. Biomonitoring studies by the CDC have found that nearly all Americans have PFAS in their blood. We are still learning about the full range of health effects, but studies have linked them to a variety of problems, including cancer, liver damage, and immune system dysfunction. Then there are phthalates. These are chemicals used to make plastics like PVC more flexible and durable. They're also used as solvents in personal care products like lotions, perfumes, and nail polish. Like PVC, exposure is widespread. A recent study published in 2024 found that U.S. preschoolers are being exposed to multiple potentially harmful chemicals, including phthalates and replacement plasticizers. Phthalates are known as endocrine disruptors, meaning they can interfere with the body's hormones. This is especially concerning for children during critical windows of development. Biomonitoring is our main tool for tracking these modern exposures. It helps us understand which of these thousands of chemicals are actually getting into our bodies, at what levels, and how they might be interacting with each other. This is the new frontier, understanding the health effects not just of one chemical, but of the complex, low-dose chemical cocktail we are exposed to every single day. This incredible power to read the chemical stories in our bodies brings with it a host of profound ethical questions. The technology is advancing faster than our ethical frameworks can keep up. For starters, there's the question of communication. If a study finds a potentially harmful chemical in your blood, should you be told? What if scientists don't yet know what level of that chemical is dangerous? This is a huge dilemma. Informing someone could cause significant anxiety and stress, a phenomenon sometimes called biochemical anxiety, especially if there's nothing they can do about the exposure. On the other hand, people have a right to know what's in their bodies. Then there's the issue of privacy and data security. Your biomonitoring data is some of the most personal information that can exist. It's a blueprint of your environmental history. Who should have access to it? Your doctor? Government health agencies? What about insurance companies or potential employers? Could someone be denied a job or life insurance because their chemical history suggests a higher risk for a future disease? In an age of big data, protecting the privacy of this deeply personal health information is a monumental challenge. We must ensure that this data is used for the public good, to improve public health, and hold polluters accountable without creating a new basis for discrimination. The future of biomonitoring is one of both immense promise and formidable challenges. New technologies are on the horizon that will allow us to detect an even wider range of chemicals at even lower concentrations. We're moving towards a world where a single drop of blood could reveal a vast amount of information about your past exposures and future health risks. But the biggest challenge is not just detecting more chemicals, it's interpreting what that data means. What is the health risk of having trace amounts of 100 different synthetic chemicals in your system? This is the central question that toxicology and epidemiology are trying to answer. The ultimate goal is to move beyond simply monitoring the problem and toward actively preventing it. Biomonitoring data can guide regulators to focus on the most hazardous chemicals, push industries to develop safer alternatives, and empower communities to advocate for a cleaner environment. It is the evidence that can turn concern into action. So, the chemical history written in our bodies is not just a scientific curiosity, it's a human story. It's a story about our complex relationship with the modern world we've built. It's a story about the choices we make as a society, the products we consume, the industries we support, and the regulations we enforce. This story is being written in all of us, right now. By learning to read it, we are not just diagnosing the problems of the past. We are gaining the knowledge and the power to write a healthier story for the generations to come. Thanks for listening to G Fun Facts Online.